Check. Yo, I think we are live. So that's cool. Happy Thursday. Happy 100K day. I guess today technically isn't 100K day. But it happened last night, so that's pretty cool. That's pretty cool. We can kind of just check that box and move on. I guess keep building. I guess so. I think that's a good thing to do. And what a great time. What a great opportunity for us to dive into another Lightning workshop topic. And so this one I'm pretty excited about. It's maybe not the most exciting use of Lightning, but it's something that's really important. It's something that comes up a lot with companies, startups, and even individuals that are building on Lightning. A lot of this has to do with insights. What can you see that's going on with your Lightning node live? What can you listen for? But then this evolves into, I think, what can you automate? What can you be smart about and write code for based off of the activity happening on your Lightning node? I think that we are still very much in the early days of Lightning and of how we can optimize Lightning in applications, in backend services. And a lot of this, it starts with monitoring. And then, of course, you gain insights from that monitoring. And those insights give you recipes or criteria or different kinds of automations or actions that you might want to take. But let's not get ahead of ourselves. We're just going to start by asking some basic questions about what can we know that's going on inside of our Lightning node? What can we see? How do we set that up? And then from there, the world is yours, right? You can listen to every kind of event on your Lightning node and do whatever you think is smart or necessary based off of that alert. Or maybe you just log it all, right? Maybe you're just collecting a bunch of data, collecting a bunch of logs, these events. But okay, nonetheless, I think we are live. I see that there's people joining, so welcome. And I think we'll get into it from here. And I'll show you, first of all, we have the completed project. It's at replit.com. This is my username, Bitcoin Pleb Dev, and Lightning-monitoring. You'll want to get access to these slides, though, because these slides will have, well, the links to everything, and they will also have all of the code. So tinyurl.com/voltage-monitoring-workshop. I feel like I should add this to the notes. I'm going to add this to the notes. I'm going to say link to slides. Tiny. What do we say? Voltage monitoring. Voltage monitoring workshop. Okay, that looks good. And I'll just scoot this over so we can actually see it. Oh, it's too long. Just say slides. Okay, cool. That really fits. Great. So those are the slides. We'll keep those up there if you want to follow along live. Of course, this will be recorded. And of course, we're going to have, well, we have it right here, a completed project. So if you're ready to just see what the code is and kind of see what I've set up, then jump right into that. Go steal and copy and tear apart that code. That would be great. But we'll kind of walk through things from scratch here. So let's get into it. So those are the links. Yeah, I've got that on the top. So the rest of y'all that are joining a little later should be good. Okay, cool. So quick overview of what we're going to talk about. We're going to talk about what can you monitor on your Lightning node? What can you see? I'm going to tell you how I think about monitoring. Originally, this point was how you should think about monitoring, but I'm not going to tell you how you should think. I'm going to show you how I think about it and a little bit. I already talked about that. We're going to talk about interacting with the LND node interface for monitoring. So there's a lot here. We'll keep it simple, though. We'll give you what you need to get going. And then we're going to build a simple Lightning node monitoring server. And this will be an example for you to take home and build on top of. And hopefully it'll condense a lot of topics, a lot of methods, a lot of things you do on LND into just, a few dozen lines of code for you. Great. So let's start at the top. what can you monitor on your Lightning node? So there's different kinds of subscriptions that you can get. Subscriptions to subscribe to certain events on your Lightning node, okay? And so channels is one of them, which makes sense. So we can monitor things like channel opens, channel closes, a pending channel, any channel balances, channel being offline, channel being online, or coming online, going offline. So basically all of our channel events there. So that's pretty nice. We have invoices as well. So we can detect when an invoice is created, when an invoice is paid, expired, canceled, and actually key send payments as well. Because normally the flow of a payment in Lightning, I would make you an invoice, I would give it to you, you would pay that invoice. But with key sends, if you know my pub key, you can actually just push a payment to me. And so we can detect these, right? Because, well, we didn't create an invoice for it. We're getting sent a payment. Well, that's okay. You can still detect it. So we've got invoices, we've got channels, and transactions is another one. This is for the on-chain wallets specifically. So, I mean, really, there's a lot of details in here, but effectively, I mean, we're going to see transactions that are sent, transactions that are received. And then the details of those transactions. So not too much else to get into with that. Next, we have what can you, HTLC events, which these are pretty interesting. These are going to be your forwards mostly, but they'll also duplicate and detect these sends and receives as well. So this is one kind of concept that's good to run into right now. These different subscriptions for these different kinds of events. I just realized I have duplicate slides. They might have events, duplicate events, basically, right? So, such as for invoices, if I pay an invoice, well, that will maybe show up on my invoices subscription, but it'll also show up on my HTLC events because I have sent a payment. This will make a little more sense when we see that the HTLC is basically, from our perspective as app developers, it's basically just this data structure that represents the low-level payment object. And best of all, when that payment object is in flight or in some process of a payment, right? So as soon as we are in the process of a payment, we can pick that up with these HTLC events, which is pretty cool. So yeah, sends, receives, forwards. Those are the payments we're routing between our nodes. And then of course we can read the amounts for all of that kind of stuff. Okay, yeah. And so that's basically, I mean, these are the primary subscriptions that you would listen to. There's other ones out there, but I think the data gets a little bit more niche, a little bit less useful and applicable to a lot of people. So this is what we'll be focusing on: HTLCs, transactions, invoices, and channels. Okay, and so how I think about monitoring, so I just threw down these bullet points, and kind of something I touched on earlier as well, but observe before automating. So much of, when we're talking to enterprises, bigger companies, companies that are maybe less familiar with Lightning, like they're so used to automating away things, processes. And we're still in the early stages of that for Lightning. It's hard to automate something that has a lot of risk to automate. For example, do you want to automate sending payments? I mean, probably not, because that means that you'd be giving some server basically your private key and allowing it to send payments on your behalf, right? So we need clever automation. And I think that comes through observing first. And so a lot of people, they set up Lightning nodes and they treat it like a black box. Maybe they try to manage their channels, but from an organization standpoint, they treat it like a black box. I want you to observe and just start to capture this data and start to look at it and understand patterns. And those patterns will show you things that you can automate. So observe before automating. It's a big one, how I think about monitoring. Next, at first monitor broadly and then create more specific criteria over time. So this is a little bit of what we're going to be doing here. We're just going to be connecting to these subscriptions and effectively logging everything, all of the data. So it's very broad. But if I was running a business, maybe over time I would find certain patterns. For example, maybe my channels are getting drained, and I might say, give me an event for any time that I'm forwarding a payment more than 100,000 sats, more than 1,000,000 sats. I would say, give me an alert, because if that's happening, for one, maybe I just want to see who it is or where it's coming from. For two, maybe I need to manually or automatically then go and rebalance a channel, something like that, or prepare to. So that can be kind of an example of a specific criteria you might look for. But of course, there's infinite criteria you could look for. So you want to look for the right ones. This is where you monitor broadly at first and then get more specific over time. And then next we have define your risk cases, your edge cases. So basically, what are you at risk with your Lightning integration? I mean, having something like monitoring, it can add risk space depending on what you're doing, such as if you're putting admin credentials on this other server. So make sure that you're not exposing yourself to more risk by doing this kind of monitoring. And at the same time, when setting up this monitoring, even though we're going to start broadly, I think it's good to outline what are edge cases you're just going to start looking for from the scratch, or things that you want to pick up on, such as routing really big payments. Maybe there's channels being opened towards you or something like that. And maybe this will trigger some alert, and maybe you'll do something based off of that. But it's good to start with something specific that you want to look out for. And I think channels draining is just probably one of the best places to start there. And then just learn from your data. Learn from your data, specify, and then simplify. So as you learn about this criteria, you'll see what kind of things you're looking for. You'll specify, you'll make a criteria to pick up something specific. I'm routing a payment of 1,000,000 sats. And then that will allow you to simplify this monitoring code and really just kind of simplify the processes on top of this. So it doesn't have to be this big convoluted server that's collecting everything. Nobody wants that. You just want to be able to keep a tap, keep a heartbeat on your Lightning node, and make sure that you're continuing to operate, right? That's the basic need that we have at first. Great. Okay, so that's how I think about monitoring. Let's get into the nitty gritty. And so we've talked about these different kinds of events we might listen for: HTLCs, transactions, invoices, and channels. But these are the interfaces that we will use to do those, or the interfaces that we can choose from. So interacting with your L&D node for monitoring. So L&D has actually 4 interfaces in total. These are just, interfaces. These are just gateways for you to talk to your node. So we have REST, gRPC, CLI, and WebSockets. And so for you developers out there, you will know REST. REST is just a traditional HTTP API. And there's very good documentation on that. We've got the gRPC, which is a live streaming connection similar to WebSockets. We have CLI and then WebSockets, right? And so this makes up for an async interfaces, which is REST and CLI. What I mean by async here is that you are making a request and then you're receiving a response at an unknown time. It's going to be pretty quick, but you just don't know when it will resolve, which is why it's asynchronous. Versus the synchronous interfaces here, they will stay open. We will stay on the phone with our Lightning node and hearing every single update in real time. So that's what's really cool about these interfaces, right? They're live streaming, listening to our node live. But there's a little bit more, there can be a little bit more code with this. And for a lot of basic applications, people just like to go with REST because it's simple. Maybe they don't need the live streaming connection to their node. That's fine. But I think in general, the gRPC and the WebSocket interfaces are pretty damn powerful, worth looking into. And let's, I'll keep this full. Let's go over to the L&D API, and I'll show you an example of this. So if we go to the L&D API, we can go into the Lightning service, and There's just so many methods here. You should check out last month's workshop, by the way. We kind of break down all the methods and categorize them and make them easy with some examples. But nonetheless, there's a lot of methods here. And most of these are asynchronous. So they simply just return a list of stuff. This actually has a gRPC interface. Yeah, so gRPC, it can still take in responses. So, you might still have a traditional request response that you can do over gRPC, but nonetheless won't be live streaming data in the same. So like list channels here, we request at this endpoint v1/channels, and we're like, hey, give me my channels, and then it outputs you your channels. There you go, request response, very, very easy. So this is what a lot of the methods look like. But then you have these subscribe methods. So subscribe, let's look at subscribe invoices. Subscribe invoices returns a unidirectional stream from server to client for notifying the client of newly added settled invoices. Unidirectional stream. Okay, that's what we call it. I would call it just a phone call. It's like a phone call instead of a text message. But nonetheless, so we can see on these code snippets, we have a gRPC code example. And actually with a lot of these REST examples, I didn't see this for the longest time. But if you go to REST under here, you will see an example with WebSockets. And WebSockets are also live streaming. So so we have two different interfaces here where, two streaming interfaces, that is. And a lot of you might be familiar with WebSockets. That might be easier for you. We're actually going to do gRPC today, which is a little bit more boilerplate. But you get down to it, and all we do is we have a request object. We're going to call the client, the specific subscription with that request. And then on data, we'll get new events. On status, we'll get new statuses. And on end, well, that'll tell us that server is closed. Great, so that's kind of the structure of what these methods are going to look like. Okay, so we have all these methods in LND. A lot of them are request response. Some of them are unidirectional streams. I don't know how to say UNI. How do I pronounce this without sounding terrible? So that's kind of the layout here. So for the purpose of monitoring, we want to use these synchronous interfaces, really. I mean, you can do monitoring with asynchronous, but what that turns into is polling. And if you don't know what polling is, it means that instead of me calling you and us having a 5-minute phone call, I'm going to text you every 3 seconds for 5 minutes, or, something like that. Text you every 20 seconds for 5 minutes. So a little bit less efficient. Sometimes you just use the full REST interface for your app and you only use polling for like 1 or 2 endpoints. That's totally fine. But if we're going to do a full monitoring suite, we want to use either gRPC or WebSockets. So we're going to use gRPC. And let's get right into it because we kind of covered the bases. We know what interface we're going to use. We know what we want to listen for, and we've kind of seen what those methods look like. And next would be actually starting to plug in those methods. So let's get to it pretty quick here. First, I will show you Voltage a little bit. Show you how to set up a development node, because that will be important for this. So you can go to voltage.cloud, and I'm already here on my team. So my whole team will be a little bit more populated here. But if you go to Lightning, you can select a new node, and you can select MutinyNet. And this will be a free development Lightning node. And it is amazing. It's one of my favorite features, one of my favorite products that we have here. And it's just because I love building on Lightning, and having a development environment that's easy and secure and doesn't cause you to lose your money can be really difficult on Lightning. And I think Voltage really solves this problem quite well. So if you go over here, you can select the MutinyNet node. You can click continue. You'll put a name and you'll need to put a password that will encrypt that node. And from there, on the other side of 10 minutes, you will have your own development node. And it will look a little bit like this. This is my development node. My dashboard is locked right now. I need to unlock it. It's my password. And these are, so this is development node. It's called MutinyNet because it's on the MutinyNet Signet. Don't worry about what that means. It just means we're on an easy testnet that makes it easy to develop on Lightning for us devs. Having a loading issue here. Unlock. But we'll just give that a second. But what we can start to do is set up our project as well. So that's how you can go through and spin up a new MutinyNet Lightning node. Now let's start to set up our app. So setting up the React app, that's not correct. Setting up the Node.js app. Live bug fixes. Okay, setting up the Node.js app. So you can either get started locally, but you must have Node.js installed, obviously. Or you can get started on Replit. This is what I'm going to do. Just make things a little bit easier, a little bit quicker. So all you need to do on Replit is create a new Node.js template. Otherwise, locally, you will kind of do the classic of, really, this isn't even complete too, because you would, make a directory and you would call it something. You would call it Lightning Monitoring Workshop. And then you would cd into it. And then you would npm initialize a project, and then you create an index.js. And that would basically give you your boilerplate project right there. Cool. Bump that down. Okay, great. But we're just going to go to Replit here. So I'll slide over, and I'm on Replit. And we can see my Lightning monitoring that I just finished editing 7 minutes ago. Let's create a new Node.js. I'm going to call it, I'll keep it private. I'm going to call it Lightning Monitoring Live. Cool. This will spin up a new Node.js template for us. Great. And we see we just have an index.js here. Okay. And from there, we will add these proto files. We'll talk about that in a second. We're going to add our host, and then our hostname and macaroon, which will come from Voltage. So let me just I think I'm going to need to sign in. Here again, my session expired. Go Austin Dev Node. Okay, that's weird. So everything is unlocked. It's just having an issue with this UI right here. Sorry about that. That's kind of weird. Nonetheless, we can grab the information we need here. Just looks a little bit different because I can get, yeah, to my macaroon and all of that. Okay, so we have our basic app set up. We have a MutinyNet node. It's unlocked. So let's keep going. So we need to add lightning.proto and router.proto to the root of our project. So what does this mean? And I have two different links here to LND. And so this is, I'm going to subscribe invoices. This is basically just a part of the boilerplate of setting up a gRPC interface. One of the reasons that so many people avoid this interface is because they look at these code examples and they're like, I don't understand what's going on here. Effectively, we are needing to take this gRPC proto, which is like a skeleton. It's like a template that describes the API. And we need to load that in to this package, to this client, basically, this gRPC client with our admin macaroon. What else do we have here? TLS path. We actually don't need a TLS cert, so that's good. So I believe just those things. Macaroon, any metadata, credentials, cool. So we pack that all into an object, and then we create credentials out of it, and then we say client equals new lnrpc.lightning, the gRPC host and the credentials. And the gRPC host is, of course, our Lightning node host. So we're basically just doing all this boilerplate to put together sort of a authorization and parsing package for gRPC. We initialize a client with this. And then with that client, we can just go and make requests, right? So it's a little bit of pain, a little bit of boilerplate up front, but we can do that once and then just reuse this client again and again. Okay, and so the proto is the map of the interface that we need to load in, and so we're going to get that from LND. So you can probably just search lightning.proto, and you'll find it. Yeah. And you can simply just copy everything in this raw file. It's just easier for me, and I'll make a new file here, lightning.proto. And I'll paste it all in. Just save it as is. And then we're going to have another one that'll be called router.proto. And let's find that. Router.proto. LND router.proto. And here this is. We're just grabbing it from the master branch. Router.proto. Beautiful. Okay, so we have that in place. We're ready to grab our credentials whenever. So let's continue on to the next step. So the host name and the admin macaroon is all we're going to need to have here. We'll grab those in a second. I mean, really, we can actually grab these right now. At least the admin macaroon. So to find that, you can go to Macaroon Bakery, and you'll find admin macaroon right here, and I'm just going to download it. And then I'm going to take that new macaroon, show it in Finder, put it right here. I need to rename it because I had another one. Be very, very careful with this admin macaroon, by the way. This is your admin credentials. Of course, we're on a development node, so we don't have to worry about that, but just so you know, always got to give that shout out. Okay, cool. So the lightning.proto admin.macaroon's in there. Okay. Now let's keep going onto the code. And the first thing we're going to do is create a main function in index.js. And this will start to show us I suppose what to expect from the rest of our code. And we're just going to copy this from the slides. We'll paste it in, and then we'll walk through the code. So index.js is right here. Okay, And so this is going to be the heart of our app. So Lightning Node Monitor is the main application. And what does it do? Initializes and runs all the different monitors. So we're going to have a few different files here. We're going to have a Lightning monitor, a channel monitor, an invoice monitor, transaction monitor, and an HTLC monitor. Now this Lightning monitor is really just going to be our boilerplate for our gRPC interface. So this is just going to spin up and initialize everything. And then the channel, invoice, transaction, HTLC monitor, these will actually be the subscriptions that we listen to. Okay, so inside of main here, you notice the very first thing we do is we say const monitor equals new Lightning monitor. So we're invoking the Lightning monitor and we're passing in these arguments. So this is where you'll first have to edit some text. So this is kind of bad. These file paths were hard coded for my original project name. So like, since my project here is called Lightning Monitoring Live, I'm actually going to change this right here to say live, and then live. Okay, so now those paths will be correct. And then this final argument here is your node's host name, and then the gRPC port. And where you'll find that on your Voltage dashboard is right here is the API endpoint. That'll be the host name. And then we see the gRPC port here is 1009. And that is exactly what I have here. Name, colon 1009. Sweet. So that is how we're going to initialize all of this, passing in the arguments. And from there, really, we just spin up these new monitors. And these new monitors, well, we spin them up and then we subscribe. And then once subscribed, these just keep on running and they will log events for us. Sweet. So let's get into next steps now. So create our main function. Let's create a Lightning monitor base.js and build our gRPC interface. So this is a lot of that boilerplate code. That's why there's so much here. And we're going to call it lightning-monitor-base.js. Sweet. I think that looks good. And we'll paste this in. Great. Now let's walk through this. So we see, at least from the top here, this is very similar to our code example. Just creating this interface. So we create our loader options, we pull in all the necessary libraries, and we actually create a class for this where we grab the necessary arguments, initialize the clients, and then in this initialize, which gets called, where does this get called? Right here, monitor.initialize. This is what will spin up our client, read in our macaroon. What else are we doing here? Create credentials, load our proto, such our router proto path. And we have another proto path. We'll talk about that more. Load package definition. And then we return this.client and this.router client. So we have two clients here. We have two clients, client and router client. So we'll talk about that in a sec. But yeah, a lot of that ugly boilerplate. There's no way around it, so better to just pack it into its own class and wrap it into a format that we kind of get. Let's initialize the client. Those clients get set, then we can just interact with them. Okay, cool. So that's our index.js. That's our Lightning kind of base monitor class. So let's get into the next bits here. So next up will be Lightning monitor channel.js, and we're going to build our channel interface. And this code is a lot more simple. Lightning monitor channel.js. We'll paste this in. So all we're doing, we have a class channel monitor. We're defining client, And then subscribe to channel events. We are simply making a call to subscribe channel events with an empty object. And then we have an on data, on status, and on end. Our end will tell us that the stream has closed. Data will be, any kind of new data, new event. And then status will be a change of a channel status, I believe, like going online, offline. And we can actually dig more into, what are we on? Subscribe channel events. And we can read more into this. Right, see, so they have an empty request. They just call subscribe channel events with an empty request. They have the same. Oh, status is the current status of the stream. Has nothing to do with any of the events or the data. Okay, so that's actually good. That's good to know. So really inside of these on data, these will be the only listeners that, I guess from a monitoring standpoint, we're really going to be kind of parsing out. Great. Where was I? Okay. Yeah, and from here you can dig into, let's see, the request or the response. I think it's just a response. I don't really think there's a request object with the channel events. Yeah, and so channel event update. Yeah, so you'll get one of these kinds of responses, and then they associate with these data structures down below, such as this is LNRPC channel. We can see that right here for open channel. And so you'll receive all these arguments. So, I mean, everything you'd want to know about the channel in question as the event fires, it's all going to be here for you to parse out. Cool. While we're here on the docs, though, I'm going to show you why. Why do we have a client and a router client? Why do we have two different clients? Okay, so this goes into the structure of LND. LND has these different top-level services. It just so happens the Lightning service is the one that we are using 99% of the time. But for one of our subscriptions, which is subscribe HTLC events, this actually lives on the router service. And therefore, we need to create a router client for it. Right? So each service, each has its own proto file. That's why we have to have a router.proto as well. But they also need to have their own client. Okay, so I think hopefully that explains all the ugly boilerplate, that explains the protos, that explains the clients. And then when we see here in channel, actually, once all that setup is done, it's quite simple. We just open up, we subscribe to the streams, and we write our code inside of this listener, or one of the other listeners. Okay, so that is Lightning Monitor channel. Let's next put together Lightning Monitor. This should be transaction, I believe should be next. .js. That looks right. Oh no, invoice is going to be next. That's okay. We'll just grab transaction right here, and then we'll do invoice after that. So here's transaction. So look at this. Almost exactly the same. The only difference is we have an argument. We actually have a start height of when we start listening for on-chain events. And maybe we should make the start height instead of 0, maybe we should make it like 800,000, right? Because is that even 800,000? Yeah, because you're not going to, you're not going to have any transactions from before block height 800,000. But of course, don't forget, we are on MutinyNet, so actually the block height will be, you can go to mutinynet.com, and we might not start until block height 1,660,223. That's pretty far. Let's just do 1,600,000. What is that? 1, 2, 3, 1, 2, 3. That's 16 million. do that. That seems like a good block height to start listening for. But anyway, yeah, so this object right here, this is where we can pass any of these request arguments. We see start height here. If you look at back into our Lightning service, subscribe, transactions, scroll down in the example, we see a little request example, and it shows us what arguments we can put in. Start height, end height, account. And of course, those are described right here in the request. Start height, end height, and there's beautiful explanations, and it tells you what type based on what interface. So nice. But for us, we just need that start height. So, okay, so that's our transaction monitor there. Next, we'll have the invoice monitor. So we'll do lightning dash monitor invoice.js. We'll go back one slide to grab invoice. Great. Once again, same exact thing here. The only difference is names, and then our argument we're passing in. We have an add index, which is basically just the when you create invoices on your node, those invoices you create, they count up from 0, just a basic index. And so you can start listening for certain invoices after a certain index, right? If you know that, oh, I was in testing period up until invoice 1000, maybe you'll have your add index be invoice number 1000. So you don't have to search over a space that you know you're not going to find your invoice at. So that's the only consideration for that. And of course, all the arguments, everything are on the docs like normal. But yeah, we just have status, data, and end here all the same. Spoiler alert, it's going to be the same thing for HTLC as well. Here we have lightning monitor HTLC.js. Let's create that. Lightning. And so remember, HTLC is our low level. How would we put this? If you know, you know. If you don't know, it's basically just the low level payment data structure that's getting passed between Lightning nodes, right? And what's cool about it is that it changes, it mutates as it's in flight. So we can listen to these events as they are in flight, listen to payments being sent before they've even succeeded. And then, of course, everything that's passing through our node in general. So the HTLC monitor is very powerful in that regard. And I just noticed we have an error here, an on error. And we don't have on error in any of the others. I wonder if that's a mistake on my part. Let's look at subscribe transactions. Yeah, they only have on status, data, end, subscribe invoices, data, status, end. I see. But of course, this is a different service, so maybe that makes sense. We have, oh, just data, status, end here as well. I'm sure since these are generic listeners, we should be able to pick up an on error as well. But yeah, definitely consider that. But of course, that's inside of the docs here. Like there's error types and all of that. It's just normally, I believe a lot of the errors actually show up under data, but it'll tell you that there's like a certain type and like an error type. Okay, nonetheless, let's get back to it. So we just put in HTLC monitor here. Cool. And yeah, much like channels, there's not really any arguments we need to pass in here. We're just going to pass an empty object and just start listening for stuff to happen. Nice. Okay, so let's test out our monitoring server next and probably try out some different alert criteria. We're already coming up on time here, so always takes a little longer than I think, but we have enough time to test things here and talk about some other criteria that we might listen for. So we can check all of our names of everything. That all looks good. Got lightning.proto. I've got my router.proto. We've got the right names inside of these paths. And then, of course, this is my node host name and then the gRPC port. So if I run this, we should hopefully start to see stuff. But we'll make some events happen as well. So let's click run. We'll need to install stuff. Okay, cool. So I've noticed this. I don't know why this occurs, but for me with the HTLC monitor, no matter what, as soon as I connect, I get this empty, unknown HTLC event. So I guess event, it says this is a subscribed event. So that's telling me I'm subscribed. So, oops. So I suppose that's good. But yeah, okay. So seemingly we're connected. Let's try and make stuff happen. So back to my node here. I really want to get this to like refresh correctly. Do I dare try and, I think it might be VPN. Let's actually do this. I'm going to open this up on another browser. I think I just need to clear cookies or something. I'm probably having a state issue. I'll just go voltage. In just a second, I just want to get into my node dashboard, and then we'll try to move some transactions and see some of these alerts come through. Okay, so that should work now. Okay, maybe it's not me. Maybe we have a bug here. Or maybe it's just a bug with my account. Yeah, it's showing everything is unlocked here. It's just not showing my balance. It's kind of annoying. Oh, darn. Okay. Well, let's get some MutinyNet coins because we can at least do that for right now. So let's just receive 100K MutinyNet coins. We can receive on chain. Let's first of all, okay, we're still running. Yep, we're still running here. I can see I have the stop button right there. So let's receive these coins on chain. We should see 2 events pretty fast. One, the transaction coming through, and then one, I believe it getting confirmed. So let's see. Receive on chain. Yeah, I might need to try another node here. I think I have another MutinyNet node. Let's try this one. Maybe it is a VPN issue, though. Okay, I'm sorry about this, y'all. I'm going to try one more thing here. See if this is a bad idea. I still connected? It says I'm still on here. Oops. Let's try it on another browser again. Okay, here we go. It's always something. If it isn't the code, it's something in the tools or something in the infrastructure. But don't worry. Get through this. Unlock. Ah, yes. Okay. So I guess it was an issue with the VPN. So here we are. This is how it's supposed to look. I'm not sure why that was happening, but we're back. Boy, oh boy. Okay, let's restart our server now that we've just run the gambit. Okay, server's back on. We're on our unlock dashboard. Now let's get some MutinyNet coins. Choose 100K here. Nearly instantly, it should, boom, just like that. We have a new event. Okay, so HDLC event was our first one. Next, we have transactions data, right? And you can see this console log inside of Lightning Monitor transactions data. And we see all this information. We have destination addresses, output details, previous out points, amount. And so that was the first, this was the first update we got. Transaction hash, and of course we have number of confirmations 0, block height 0, right? So it's basically just on, it's just in the mempool. After that, we got another event because we have very fast blocks on our testnet that came through, and then now we have a block height 166 or 1,660,000, and we have one confirmation on here. Beautiful. And I think we'll get a second confirmation like once another block goes by on MutinyNet. Like we can, look at that, it just happened. Our last one is 249. But yeah, I guess it'll only tell you for the first confirmation. But okay, cool. So we see our transactions monitor. This piece is working. And there's all sorts of interesting things here that we can look at, such as amount, such as the script types, all of that. Maybe not too much common here that we would automate on the other end of our monitoring here. But okay, cool. So that's testing for transaction. Let's try to get a channel now, a new channel, so we can have a channel open to us from the faucet as well. Let's just do another 100K. And we can have, when they open a channel to us, we can have them push sats to us as well, 25%. So let's go ahead and do that. And we should see something here. Okay. And now let's scroll down. This was our one confirmation message. Oh, look at that. We have another transactions data. Oh, yes, of course. Of course, of course. We have another transaction monitor because, well, we're having a channel opened up to us. But obviously there's an on-chain transaction associated with this channel. So we get this transaction right here, and we see that there's two different amounts. Amount for a fee. Amount over here, what is that? 704,000. And then 75,000. Okay, and then finally we move on from there. We have our first channel data monitoring. We can see that right here, channel data. And the type is we have a pending open channel. So that's just that little object right there. We have more transaction data right here. This was our open channel. It came through. This is our open channel confirming. Transaction data. And then next we have channel data, and the channel is no longer pending. It is opened. We see active, true. We see the capacity, remote capacity, all of that. So we have our open channel event, and then another one, active channel event. There's a new active channel. A channel has gone online, basically. So cool. So that was a lot, just kind of cascading just from one event. So you can see how there's a lot of data, but you can also see how we can very easily start to parse through this and be very specific about what we want to listen for, what we want to be alerted about. Great. So that has shown us a little bit from our channels, our on-chain. Let's actually try some payments now. So we can have this is a MutinyNet faucet. You can go to faucet.mutinynet.com. And it just has a few more options for kind of faucet stuff that isn't necessarily on the Voltage dashboard, because we just have channels and on-chain. But what I want to try next is I want to get paid a Lightning payment by the faucet. So what we can do for that is I'm actually going to use the API for requesting an invoice. So we've got my dev node here. I'm going to ask for a new invoice from here. So we can say, is it value or amount? I think it's value. Be like, let's say 1,000 sats, and it should be V1 invoices. This is us just using the REST interface here. Cool. And I'm just grabbing, here's an invoice for 1,000 sats. Okay, so now first of all, invoices data. I just created an invoice through the API. So already before anything has been done with that invoice, we see all of the info about it, right? If I'm a company, maybe I'm the one that made the invoice. Maybe a user is hitting my Lightning address and making an invoice on their behalf, right? So this is how to detect that. So we see that new event here. Let's clear, or let's stop this. We'll clear it and let's rerun it. Okay, so I created that invoice. Let's see what happens when it gets paid. So I can go put my payment request inside of here, say strike me now, and hopefully, okay, yeah, they're able to pay that 1,000 sat invoice. And what did we get here? HTLC event. This is a settle event. We have an invoices data event following that, which tells us that it's settled. And then it's followed by an HTLC event, and this is the final one. So this is sort of like, event type receive. So our first settle event. Okay, so yeah, on this first one, we're receiving and we're kind of starting the process. We're trying to settle, and then we get the actual invoice data updated. And then the HTLC event tells us, okay, this is the final HTLC event. And this is basically our us passing back to our peer, hey, the invoice was settled. Here's the final HTLC event. So that's a little bit of that flow going through. But goodness, you just see how much you start to learn, how many questions start to rise up. As soon as you're exposed to this low level of the flow of funds, the flow of data between the two nodes, there's a lot that you can learn through digging into these interfaces, just a little bit deeper than most people do, just a little bit deeper. Cool. And so we've had an invoice paid to us now. Let's pay one of MutinyNet's invoices and see what that looks like. And I think that would be a cool way to kind of finish things off. So we can go back to the faucet, mutinynet.com, and scroll down, and you can find their LN URL right here, refund at lnurlstaging.muniwallet.com. So what I can do is I can take the domain part of this, and I can say slash dot well known slash lnurlp slash refunds. And this will give us this object from the callback. I can request an invoice with a query parameter of an amount of 1,000. If you're not familiar with this flow, this is just the LNURL flow, which is a flow for kind of having a payment method that sits on the other side of a URL. This is what that URL looks like, kind of like an email address. And we can parse it in this certain way and get this object, which then gives us a way to request a new invoice to pay the MutinyNet faucet. So they gave us this invoice. I think I said 1,000. So I think that's actually just 1 sat since it's millisats. So nothing new here, right? Nothing's happened with our node yet. But what I can do here is through the API, I can pay this invoice. So I can go v1 channels / transaction. I think it is transaction. And it'll be a post, and I'll say payment request is equal to this string that they gave me, channels transaction. Okay, let's see if that works. Not found. V1 channel transactions, not found. Okay, let's find this endpoint. This is, we're just trying to send payment, so this will be send payment sync. V1 channels transactions. They're both plural. I see. Channels transactions send. Okay, and we get a 200 success. And back here in our monitor, we see 2 HTLC events. One of them is a forward event. But of course, the type is a send. And we see the outgoing amount, right? So that tells us this is going out from us. And then we get another HTLC event in which it was a send and it was settled. Of course, we have the pre-image right here. It's in a bunch of bytes, and that pre-image is what gets revealed, what gets passed back to our peer when they get paid. And this is basically their proof of payment. So, okay, so that's kind of the basics. So we've kind of triggered all of our different monitoring interfaces. We see how they overlap, how they get triggered for similar kinds of events. And now the real unlock, the real next step in all of this would be add criteria. I spelled that wrong. Criteria. Right? Inside of this on data, we might say if amount equals this and this thing is this, right? We can just start to add all of these different conditions to then say, do something cool, right? If it meets that condition, or just maybe we just say, you know, alert backend system. But it's inside of this on data, and with the knowledge of the interface and what you can expect to return back, that is what will let you dig in to deeper, more meaningful alerts and be a little more intelligent with it. You see, obviously, when we're just logging literally everything, there's a lot of data. It becomes noise. So yeah, just break down into that criteria and go deeper with it. And so, yeah, maybe we'll kind of expand on this workshop in the future, because I didn't get to some of those things, but like something I wanted, an example of what I want to show you, which, I mean, we could probably like pseudocode out here, is like, you know, if we are forwarding a payment above X, we might want an alert. That might tell us there are channels draining on your channel. We might say if channel X reaches balance of Y, do something. For invoices, maybe if yeah, I'm not sure what we'd want to check with invoices. I might even just want to do like spam prevention with invoices. I might say if, no, maybe not something like that. But, you know, maybe checking for amounts, checking for minimum amounts, maximum amounts. Yeah, I forgot. I had some ideas for criteria of what you might listen to on invoices. But honestly, this is usually pretty basic. Like, you might use the subscribe invoices just to check if, hey, the user requests this invoice to pay for a service. Now I want to listen live and see if they paid for it and just give them an update as soon as that happens. So that's a lot of what happened on this interface. But okay, nonetheless, we have our boilerplate code down here. All seems to work. It seems to be pretty modular. And we've kind of triggered every kind of event we can in at least an hour. So I hope that was useful and hopefully enlightening a little bit. Some of this stuff, yeah, I mean, just very few people end up interacting with the L&D interface in this way or going this deep. I think there's a lot to learn. But yeah, so that is our Lightning monitoring workshop. Yeah, keep an eye on the completed project. I'll probably make a few updates. I'm going to add that to our voltage replit as well. It's kind of a long living example. Yeah, and I mean, maybe we'll build on top of this workshop and really create a actually intelligent system on top of our node instead of just an example. Because now the example is in place, it just works. So it's like, what do you want to do with it? What do you need to detect? But I'll tell you this, next time I have a, Voltage, one of our customers, one of the companies that uses our product, when they come to me and they want to know about how do I track this? How do I get alerted about this? I'm going to be pulling this example because I made it for myself and for them and for you, but wanted to make it simple because, yeah, could be so much to these interfaces. It can be a lot to parse out, but really what we're doing here is pretty simple when you get down to the bare bones of it. But okay, enough ranting. Once again, happy Thursday, happy 100K Thursday. And yeah, reach out to me if you have any questions. I'm in the Voltage Discord. I'm on X, on Nostr. Yeah, I don't know. Let's build on Lightning. Let's level up. So sweet. I will see you next time.